Welcome to this episode of Mr. Lehman's Knowledge Explosion. In this episode, we're going to be looking at the converse of all the properties we have from Lesson 1 about parallelograms. So you'll notice on page 2 of your workbook, I've listed all the 4 properties of parallelograms that you're supposed to know. I've also listed the converses, which are also true. For example, if I tell you something is a parallelogram, then you know that the opposite sides are congruent. The converse of that statement is that if the opposite sides are congruent, then the quadrilateral must be a parallelogram. Well, we're going to see if that is actually true. The second one, if a parallelogram is what I give you, then the opposite angles are congruent. We know that to be true. If I write the converse of that statement, it says, again, if the opposite angles are congruent, and that's what I know, then is it true that the quadrilateral is a parallelogram? And for simplicity's sake, this is all true. All these converses are true. But what I want you to do is turn the page, and there's one word that we have to add to each of these converse statements. For example, these are the ways that you prove a quadrilateral is a parallelogram. If both pairs of opposite sides are congruent, then it's a parallelogram. So you need to see it marked as not just, oh, hey, I have one set of opposite sides. You need both pairs marked congruent, and then that definitely has to be a parallelogram. For the second one, it's not enough to say if the opposite angles are congruent. If all you have is one set of opposite angles, that's not a parallelogram. But if both pairs of opposite angles are congruent, then you are forced to be a parallelogram. The third one, if one angle is supplementary to both of its consecutive angles, this one you actually need the numbers. If this angle up here in the corner is 100 degrees, and you know that this angle down here is 80 degrees, that's going to tell you that the top line and the bottom line are parallel, but one set of parallel lines is not enough to be a parallelogram. We would need to know that this angle also next to the 100 degrees, or consecutive, is 80 degrees, making it supplementary, which then tells me that both sets are parallel, forcing me to be a parallelogram. So again, that key word in all of these is both. That angle has to be supplementary to both of its consecutive angles. And then the last one, we learned that if I have a parallelogram, the diagonals bisect each other. And the converse of that is true. If you draw the diagonals and you're given the information that diagonal 1 was cut in half and diagonal 2 was cut in half, then you are safe to assume that that is a parallelogram. So not a lot of new information here from lesson 1, but again, understanding the idea that the converse is going to reverse or flip the information that you are given first. So pay very close attention to that. So let's see how these theorems are going to be used. In example number 1, the question is simple. Is this a parallelogram or not? So I look at this and I see, oh, I have one pair of opposite angles congruent. Well, I'm supposed to have both pairs of opposite angles congruent, so I'm going to say no, this is not a parallelogram. I need both pairs of opposite angles. And I'll jot that down. You might want to write that note down too, so you remember that. But if you look at example number 2, to the right of that, I notice that I have one set of opposite sides congruent. That's not enough. But I also have the second set of opposite sides marked congruent. So this is enough for me to go, yes, this is definitely a parallelogram because both pairs of opposite sides are congruent. And if you get in the habit of writing down the reason as you go, when you go to do a proof about these things, these become the reasons you're saying something is a parallelogram or not. So let's look at the next example. Now, on the next example, I notice that I have one pair of congruent sides. That's not enough, but there is more information to go off of. I notice that this angle up in the corner is congruent to this angle down here. Now, those are alternate interior. If my alternate interior angles are congruent, then the lines that made them have to be parallel. And I have one set of sides congruent and one set of sides parallel, but that's not enough. So I'm going to look at the two triangles. This triangle right here would have that diagonal which is reflexive to itself, which means I have a side and an angle and a side that is matching up exactly to a side, an angle, and a side. So these two triangles are congruent by a side angle side. Well, and if they're both congruent by side angle side, then that means I should be able to mark things like this side and this side by CPCTC. And now I do have a second set of sides that is congruent. So if I look, I have the exact same markings that I had on the last example. It just took me more time to find that. And that will come with practice. So this is, in fact, a parallelogram because both pairs of opposite sides are congruent. Now this is kind of a special example. I hope you noticed all the things that I was doing and you understood that, where I got the congruent triangles by side angle side and took the sides by CPCTC. What I'm going to do now is erase that, and I want you to make a very special note. We're going to go all the way back to what I originally started with and look at what we had. We had one set of sides that was parallel and congruent. So this side was parallel and congruent to that side. And we ended up at yes, that is a parallelogram. So from here on out, we're going to add one thing to our list. We're going to say if one pair of sides is, here's that key word, both parallel and congruent, then it's a parallelogram. And I'm going to use this symbol for parallelogram. So this reason would be okay. Both sides opposite were congruent, but it took a lot of work to get that. In the future, if you notice that you have one pair of sides that's parallel and congruent at the same time, that's enough to say yes. So keep that in mind and add that to your list. Next example, we are given that AD is congruent to BC. So this segment, this diagonal AD, is the same as this diagonal BC. If I go to my list of reasons, I don't know that both pairs of opposite sides are congruent. I don't know that both pairs of opposite angles are congruent. I see no numbers to see if my angles are supplementary. And I don't know that the diagonals are bisecting each other. Just because they're congruent doesn't mean they meet perfectly at a midpoint right here in the middle. And I don't have what I just said of one pair of sides that's both parallel and congruent. In fact, I have no parallel here. So I've exhausted the list. None of those things were true. So I'm going to say no, I don't know if this is a parallelogram or not. None of the things held true. If we go down and we look at our next example, I see a 35-degree angle, alternate interior to a 35. Well, that means these two sides are parallel because the alternate interior angles are the same. For the same reason I get a 40-degree angle and a 40-degree angle, those are alternate interior, which means the top and bottom are parallel also. So this isn't a property, this is actually the definition of parallelogram. So I'm going to say yes, because both pairs of opposite sides are parallel, or that's the definition of a parallelogram. So don't forget about that. Just finding parallel sides makes it a parallelogram. And then the last example here, I noticed that this diagonal is being cut in half because those two parts are congruent, making this point right here the midpoint. And I noticed that this diagonal coming down this direction also got cut in half. So this is definitely a parallelogram because the diagonals are bisecting each other in this quadrilateral. Diagonals bisect each other. So that's how you're going to use these theorems to simply determine, oh, I'm definitely looking at a parallelogram, because now, once I've decided it's a parallelogram, I go back to the previous unit and I say, oh, now I know the sides are congruent, I know the opposite angles are congruent, I know the diagonals bisect each other, and all those things will be true because we've decided that it is a parallelogram.